Hey guys, this is David, the leader of the Hurricane Watch Central North Atlantic Forecast Branch, and here I am with a video today on the severe weather in the Ohio Valley and Iowa region. As you can see here, we have an enhanced risk for pretty much almost the entirety of the northern half of the plains, and of course some parts of the Great Plains here as well. We've also got this enhanced right here for areas like Omaha, Nebraska, Louisville, Kentucky, Lincoln, Nebraska, Des Moines, Iowa, and Little Rock. Of course, these areas both here have a 10% significant risk right here. As you can see, one right here from Omaha leading up into the Des Moines region. Then we've got this one right here that includes Louisville and Evansville and parts of Cape Girardeau. This is the 10%. The 5% extends down here. It includes Indianapolis, St. Louis, places like that. The 2% is much more expansive and also goes down here into Texas. The wind risk today is rather high. I think this is probably the leading thing with these storms is the wind risk today. I'll get into that in a minute as to why I think it is. And of course you can see that it includes the pretty much the entirety of the southern half of Iowa. And then of course this part right here in the Ohio Valley region, parts of the Mississippi Valley region. And hail, pretty much, 30% significant risk of it here. Not really much here in this area. There's more or less a wind risk in this area. And I'll explain why that in a second. This right here is the sounding from the National Weather Service Storm Prediction Center. This is sent out by the Omaha Forecast Office every time at 12 Zulu and 0 Zulu, which is 8 o'clock p.m. and a.m. Eastern Daylight Time, which for them this would be 7 o'clock a.m. and p.m. So you can see right here we've got a pretty decent inversion. If you don't know what an inversion is, to basically explain it, is when the temperature at the surface or anywhere in this pretty much, I can show you an example of that, where the temperature at one point is lower than it is above. So right here, as you can see, the temperature is above what it is down here. So this would be an inversion, especially since this is at the surface. Surface inversions tend to result in lower clouds down here. So that's typically what you'd see with like fog and stuff like that. Usually also these being close together also indicates fog. And as you can see right here, this little dotted line, that's the parcels. Basically, the air has to rise for it to be convection. It's kind of like, think about you bubbling up a pot of steaming hot water. Let's say this is your pot right here, this is your water. The bubbles have to start from the bottom. That would be your air parcels. They have to start from the bottom, work their way up, and then they finally come out at the top as that little bubble you see. That's pretty much how air parcels work. And if there's something that's obscuring it, then that's pretty much a cap. That's capping the bubble, which is the air parcel. So that's pretty much capping this. That's what a cap is when you hear it in severe weather on like the Weather Channel. They're talking about where the air parcel can't rise. It's being blocked. So this little part right here, as you can see, is doing this. That's pretty much it being blocked right there at the surface. So little to no convection can come off of that, and that's why you usually see fog with like stable days, where like the air is pretty stable. And yeah. So this is one out of Springfield. This one does not have an inversion, as you can see. Most of its parcels is pretty much straightforward. There's a little bit of a dent here, but I wouldn't call that an inversion or a capping. This is pretty much straight up. But there's not much energy with this because, as you can see, the temperatures aren't the warmest. And this thing is really saturated throughout, so there's not much of a difference. The entire thing is saturated almost all the way up to 12,000 meters. So this is pretty much just a rained out. And this was at 7 o'clock. And I believe this rain shield was over Springfield during that period of time. So that's probably what it's picking up there. And I'll get to this rain shield in just a minute. And here you go. This is an example of a cap. You've got your temperatures rising normally, then you've got this nose. that nose right there is the cause of that nose right there is the reason that convection can't rise here. So these storms would be very small. Like storms could really only form in this little area. This LCL, that's the low clouds. It's called lifted condensation levels, but that's really where you start seeing clouds form. So the clouds will be really low. So this will be like stratiform, like rain, like just your usual like stratus clouds with rain, just showers, nothing crazy. That's pretty much what this would indicate. And in winter months, this would actually, if you lower this all the way down to here and you had a wind like the nose pop out there, this would be good for freezing rain too. But then again, we're not really talking winter weather here. We're talking severe weather. Don't know why I just went off topic there. And of course, this is central Illinois. Same situation. Really heavily inverted there. It's almost like 60 degrees in this one area here, and it's 46 right here. So, yes, that is definitely something there. Moving on, as I was talking about the precipitation shield, I'll move over to GR Earth for this. As you can see here, there is a large precipitation field throughout this region, and this is what looks like the beginnings of that MCV slash severe line. This one actually produced a 60-mile-per-hour wind gust in this area, southern Oklahoma. I think it was over here near Purcell, in that area. And as you can see, it looks like the line's actually building up too. I can see it right here. It's like the line's trying to build up, especially from that right there. And then we've got like another line, which that could be also building up, but I'm not sure what that's trying to do. We'll just have to monitor that throughout the day to see what it does. But this rain shield is my main concern. You're probably wondering, but why does the rain shield matter? I thought today was a severe weather day. You're right. Today is a severe weather day. One second. The SPC has outlined 2 areas of enhanced risks. You are right. But the rain, look where it's in. It's in those enhanced risk areas. And rain, especially this much rain, can cool the air down, or it might even warm it up. In this case, I think this is a warm front moving through, which, if there's rain in the area, it's going to knock down your CAPE values, which is going to knock down your chances of having convection popping up and bubbling. Unless you're up here in the Iowa region, which I believe this is more fueled by the cold core and the shear in that area. So that may be an exception to this. But this area, I believe, is driven by like the wind threat here, which if there's no fuel, these storms won't want to continue on. Like right now in Oklahoma, if I let me actually turn off the SVC and turn on mesofill. This is surface-based CAPE. You're probably going to want to look at mixed level CAPE, which is ML CAPE. As you can see, there's not a lot, but there is at least some in this area. There's a little bit over here in Arkansas. Most of it's in the Texas region. There's a little bit of a nose trying to stick up here. But other than that, it's non-existent in these areas. And it has to do with the fact that the rain is affecting and taking the energy out of the atmosphere. Because any storm, it doesn't have to be convective, can take away convective available potential energy, or CAPE. It can take that away. Any storm can. So, with that being said, and the fact that if I look at this now, the rainfall in these areas have been rather interesting. Right now, it's been anywhere between an inch to half an inch. So, and just in the past hour, some of these areas have received that said half inch. So, that being said, the rain is definitely going to hamper down a bit on the severe threat, I think. If not, I could be wrong, but nonetheless, keep monitoring your local storms, like your local news. Keep an eye on your National Weather Service. Keep an eye on the Storm Prediction Center, because this day could wind up being. It could actually be. I could be wrong here. And oh, this map just updated. ML Cape is increasing in these areas. Of course, there's little to no rain in these areas, but note where this rain shield is here and how there's a hole here. That's just something to note there that I just thought of. And this is moving up northward, but slowly. It is currently 11:30 my time, so that could also be playing a factor in this as to why it's slowly moving up. But there is a good chance we could have some severe weather today. But I think the rain here may have hampered some of the potential today. if there is any potential, it won't be from the Cape. It'll be from the shear. There is a strong low-level jet kicking up today, I believe. If I actually turned on the EBWD, yeah, there's a strong low-level jet that is kicking in today, and it's supposed to be upwards of about 50 to 60 knots. So with that being said, we could actually have a potential for a high shear low cape event, which those do typically produce, but I'm not sure how much. I'm not sure if the 10% will actually verify in terms of the tornado percentages. I'm not even sure if the 30% wind will verify. Up here in this area, they're really predicting a lot, and I'm not quite sure how that'll go. But anyways, thank you guys for watching. I do appreciate you guys for watching this video. This is just a quick little video I decided to make just to explain this situation and what's going on. I could be totally wrong. This may not even formulate at all, and this thing could completely over verify and go right over what I was saying. But I'm just saying, don't be surprised if little to nothing occurs today, because usually when you see rain in the morning like that, and it's a large precipitation shield, it typically tends to hinder storm developments later on in the day. I could be completely wrong, but we'll just have to see. Anyways, thank you guys for watching. I will see you guys in the next discussion, whether it be for hurricanes or yet another severe risk. Anyways, thank you guys for watching and have a good one. Stay safe out there.